In this lesson, we're going to do a basic review of theorems relating to circles. So let's start with a circle, and let's draw a line segment. A line segment in a circle, which extends from one point on a circle to another point, is known as a chord. So we have chord AB. Now let's draw the radius in such a way that it's perpendicular to this chord. So let's say this is the center of the circle, point C, and then this is point D and E. So you need to know that if CD is perpendicular to AB, then CD bisects AB. So if CD is the perpendicular bisector of AB, that means that AD and DB are congruent. And if that's the case, that means that D is the midpoint of AB. So that's one theorem you need to know. So anytime that you draw the radius of a circle in such a way that it's perpendicular to a chord, then the radius bisects the chord into two congruent parts. And a point of contact represents the midpoint of that chord. Now let's say if we have a circle, and if we draw a chord that passes through the center of the circle. So let's say we have chord AB, and it passes through point C, where C is the center of the circle. That chord is now known as the diameter. The diameter of a circle is equal to twice the radius. So CB represents the radius of a circle, and AC represents the radius of the circle. So this is also the radius of the circle. Anytime you draw a line segment between the center of a circle and any point on a circle, that represents the radius of the circle. Now, if you know the radius of a circle, you can easily calculate the circumference and the area of the circle. The circumference of a circle is 2 pi r, and it represents basically the perimeter around the circle. So that's the circumference. The area of a circle is pi r squared. So we need to calculate the area of the shaded region. You could use that formula. Now let's talk about congruent chords. So let's say if we have a chord here and another chord here. And let's say this is AB and chord CD. Let's say we have center E. Let's call this F and G. So let's say that EF is congruent to EG. What's true? You need to know that if two chords of a circle are equally distant from the center, then they are congruent. Because EF is congruent to EG, that means that AB is congruent to CD. Now, let's say that EF is perpendicular to AB. That means that EF is the perpendicular bisector of AB. So AF is congruent to FB. And if EG is perpendicular to CD, that means that CG is now congruent to GD. Now let's talk about arcs and central angles. So let's say that point is the center. So let's call this A, B, C. So we have a circle with center B. Now, angle ABC is known as a central angle because the vertex is on the center of the circle. So B is the vertex. Now, you need to know that the measure of a central angle is equal to the measure of the intercepted arc. So angle ABC and arc AC have the same measure. So let's say that angle B is 60. That means that arc AC is also 60 degrees. Now, arc AC is a minor arc. A minor arc is greater than 180. So a central angle is usually associated with a minor arc. A semicircle has an arc that is equal to 180. So let's say if we have some point X, which I'm going to put that in red. So the major arc would be arc AXC. You need 3 letters to determine direction. So this is arc AXC. It's greater than 180. Arc AC, you don't go this way to go from A to C. You take the shortest path when you have 2 letters. Arc AC is 60. So arc AC is considered to be the minor arc. Arc AXC is the major arc. Now, if you wish to calculate the major arc from the minor arc, it's 360 minus the measure of the minor arc. So 360 minus 60, that means arc AXC is 300. Now let's talk about tangent lines and secant lines. A secant line intercepts the circle at in secant lines. A secant line intercepts the circle at 2 points. So in this case, at point A and point B. A tangent line touches the circle at exactly 1 point, and I just missed that circle, so let's do that again. So this would be a tangent line. It touches the circle at point C. Now let's say if we have center D, and if we draw the radius of the circle to the tangent line, it's going to meet at right angles. And this is always the case. So let's say if we have another circle, and we decide to draw the tangent line right there. So if you draw a segment between the the center, and we decide to draw the tangent line right there. So So if you draw a segment between the the center of the circle, to the tangent line, which represents the radius of the circle, then it's going to meet the tangent line at a right angle. They will always be perpendicular. Now, another theorem that we need to keep in mind is the two-tangent theorem. So let's say if we draw two tangents extend from a common endpoint. So let's say that common endpoint is point B. And we have a center D. So this represents the radius of the circle, and this is also a radius of the circle as well. You need to know that the two tangent segments, segment AB and segment CB, they're congruent. So they're the same. Anytime you have two tangent segments extending from a common endpoint, those tangent segments will be congruent. Now, AD and DC represents the radius of the circle. So those two are congruent. Therefore, the radius will always meet the tangent segment or tangent line at right angles. In this case, we're dealing with tangent segments. Now you can prove that AB and CB are congruent using the hypotenuse-leg theorem. Notice that they share a common side, DB. So using the HL theorem, you can prove that AB and BC are congruent. You also need to use CPCTC. Now the next term we need to talk about are tangent circles. So what exactly are these things? Two circles are tangent to each other if they intersect at exactly one point. So let me draw some pictures that will illustrate this. So those two circles are tangent because they intersect at this point right here. And here's another example. Those two circles intersect at this point. So these are tangent circles. Now, on the left, those two circles are internally tangent to each other. And this is because one circle lies inside of the other. On the right, the two circles are externally tangent to each other because each circle lies outside of the other. But they're still tangent circles because they intersect exactly at one point. Now, the next topic that we need to review are common tangents. So what are these exactly? A tangent is common to two circles if both circles lie on a tangent line. So let's draw two circles. Now, here's one tangent line. It's not a perfect line, but we'll make it work. So let's call that tangent line AB. So notice that that tangent line touches each circle exactly at one point.